Go with Greek. Okay. All right, so let's just do a couple more examples. Okay? So our second example, solid calcium carbonate.
Actually, no, I lied. I think it might be Latin.
You think so?
Yeah.
Oh, okay. All right. Solid calcium carbonate is heated and turns into solid calcium oxide and carbon dioxide.
All right. Solid calcium carbonate. All right. Calcium carbonate. Calcium is Ca. Carbonate is CO3.
All right. Before we do that, I think we need to figure out what the formula of this, because this is an ionic compound.
It is.
And we have to sort of play the
Roman
numeral charge game.
No Roman
calcium is Ca. Now there is no Roman numeral. Why not?
Because calcium is not a transition metal.
So I have to play I just look at the periodic table.
Yep.
And so if I look at the periodic table, here is calcium right here, and calcium is is +2. Okay, so if it's +2, because he's in the column +2, that's how we figure that out. So I'm going to write +2 right here. And then carbonate. Now, how would you find what is carbonate?
That's a polyatomic ion.
So where would I find that?
On your polyatomic ion list.
Yeah, so that's CO3. We have it memorized, -2.
Mm-hmm.
Now, do the charges add up to 0, Mr. Sanders?
They certainly do.
Well, this is an easy one, man.
Yeah.
CaCO3 solid.
Because it said so.
And it's heated and turns into. I'm going to write an
arrow.
And actually, we should add something. When you heat something, there's a little things that you put down below here. This is this little triangle. It means
goes above the arrow, doesn't it?
I don't think it matters.
Oh, okay.
Heated.
Somewhere near the arrow?
Yeah.
All right.
Can go above or below. I don't think it matters.
All right.
If you want to put it above, knock yourself out. Yeah, I think maybe you're right. Probably more convention, but I don't think it matters. Yeah. All right. That means it's heated. And it turns into solid calcium oxide. Oh, I got to play that game again.
We got to do the charge game again.
So the charge of calcium is +2, and then oxide.
Yeah.
That'd be O2, right?
Yeah, no.
Why not?
Because oxygen.
But it's oxygen. We just learned it was 2.
Oxide is in a compound. It's an ion in a compound.
All right, folks, that's very important to understand. Is this just going to be O with a charge? Do not. Its charge is -2, because if you look on the periodic table, I'm not going to flip there, but it's in the column that's -2. So this is easy. I'm put calcium with oxide.
CaO.
Charges canceled. This one's an easy schmeezy, Mr. Sam.
It is.
And it's a solid. It says it's a solid, right? It says solid calcium oxide.
Yep.
And I would know that. Well, we'll talk about that later. And carbon dioxide, CO2. And that's a gas.
Yes.
And we're done.
Yeah.
Now, by the way, there is something about balancing reactions, which we're not balancing these reactions, folks. That's going to come in our second podcast. And so even though this one actually is balanced, we may have ones that are unbalanced. And you might say, where'd the extra O's go? We'll show you in the next podcast. Okay? I think we've got one more example.
I think you're right.
Example number 3, aqueous silver nitrate. Ooh, there's that aqueous thing we talked about.
Yeah.
Silver nitrate. Okay. So, silver.
Yep.
Ag.
That has a +1 charge.
Now that's a weird one. It is a transition metal, but it's one of the exceptions to the transition metal, sort of the exceptions to the exception, so it's always +1.
Yeah.
And then nitrate.
But it probably wouldn't be wrong if they put silver Roman numeral 1.
No, that'd be fine.
Yeah, that'd be okay.
Yeah, okay, and nitrate has a charge of -1. I got that from your periodic table.
+1 -1, that adds up to 0.
Yeah, so that'd be AgNO3.
Aqueous.
And I'll put a little AQ. Reacts with aqueous sodium chromate.
Okay.
All right,
This
sodium
one's
is
not gonna
in A, and his charge is +1.
Yep.
And then chromate is from the back of your periodic table, CrO4 -2, so, or whatever your polyion list is. Those charges don't have to 0, Mr. Sims.
No, they don't.
So that's going to be.
We need 2 sodiums.
Yeah. So guys, we've done this before, but it's just good review. Na2 CrO4.
Aqueous.
Yeah, and that's going to be an AQ here. And it makes solid silver chromate. All right. So I'm going to put the silver with the chromate. Those don't add up to 0 either.
No.
But I need
Ag2
2.
CrO4.
The reason, of course, is you need to have 2
And that's a
positives.
solid.
And that's a solid. And then we're going to make aqueous sodium nitrate. That's these 2 guys put together. So that'll be in. They do add up to 0.
Yes, they do.
Now, folks, one thing I want to say here is I like to have, I sometimes call this section right here my scratch pad, where I write out the ions with their charges. And then I figure out what their formulas are.
Yeah.
So this is the answer. We have now converted this to a chemical equation in the formulaic sense from words.
There it is.
Okay, pretty easy.
Yep.
All right. Now, let's talk a few minutes about the states of matter,
Yeah.
okay? This last set of problems, it talked about the states of matter,
Right.
and I told you what they are, but there's actually a way to predict what the states of matter. It depends on the type of substance they are. So let's take a look at one substance. First of all the examples we want to talk about, we will assume that they are at room temperature. Anything can be turned into a liquid or a gas
If you get it hot enough.
if you get it hot enough.
Yeah.
All right, so let's assume at room temperature what states of matter are these. Okay. First of all, let's talk about ionic compounds. You know, I think we ought to just watch a quick video.
Let's do that.
I think that's probably easier. So let's watch a quick video on it. So how do you know what the state of matter is of an ionic compound? Now remember, an ionic compound is a bond between a metal and a nonmetal. Well, I happen to have some here. If you look down here, sodium hydrogen carbonate, NaHCO3, metal to nonmetals. Looks like it's a solid. If we move over here to ammonium chloride, it's sort of a, it's not really, it's a cation to an anion. That's still ionic. Guess what? That'd be a solid. If we run over here to copper chloride, oh, nice pretty blue stuff, right? Metal to nonmetal. That would be a solid. Yeah, and we go to calcium chloride, that's a metal to nonmetal. Looks like it's a solid.
Look, it's a solid.
Guess what, guys? And we go to sodium chloride, solid. We go to aluminum sulfate, solid. Guess what? Most ionic compounds at room temperature are solids. In fact, all, not most, all of them are. Ionic compounds. So, Mr. Sams, what state of matter are ionic compounds?
Solid.
Okay. Ionic equals solid. All right, I'm good.
Okay.
All right, let's take another one. Let's talk about
at room temperature.
At room temperature, a
covalent
compound.
Okay.
Hey,
perhaps we should watch another video.
Video time! How do you know if a molecular compound, a covalently bonded compound, what state of matter is it? Okay. Well, I happen to have a container filled with water. Notice water is a liquid at a room temperature. Now, not all covalent compounds are liquids, but I have another example over here. If we jump over here, I have hydrogen peroxide, also a clear liquid. Now, they're not all liquids. Some of them are solids. Actually, here's kind of the general rule of thumb. The higher the molar mass, remember we learned about that in the last unit, the higher the molar mass, the more likely it is to be a solid. The lower the molar mass, the more likely it would be to be a gas, and in between would be a liquid. So, for example, I'm exhaling carbon. Oh, that blew Mr. Sam's way. Okay, I brushed my teeth. Carbon dioxide. Carbon dioxide, CO2. Carbon and oxygen, both nonmetals, and that's a gas. But CO2 only has a molar mass of 44, so relatively low. If I take something like sulfur, which is actually S8, its molar mass is 32 times 8, and sulfur is actually a solid. So it depends. So it sort of depends with your molecular compounds. There's no hard and fast rule like with ionic compounds. All right. So what state of matter are covalent compounds?
It depends.
Yeah, this is the depends one. Yeah. So yeah, hard to say. If it's All right, let's do one more.
Okay.
What about just elements by themselves?
Elements. You know what I think we should do?
What do you think?
Watch another video.
All right. Hey, now I want to talk about is how do you know what is the state of matter of elements? So, for example, I happen to have a bunch of pennies in my hands. Well, they're solids. Well, pennies are made of copper. Well, copper is an element of the periodic table. So if you go over here to copper, you'll notice, well, on our periodic tables in our room, the copper is actually colored black. So guess what? Black stands for solid. Okay? But not all elements are solids. Some are liquids and some are gases. Turns out there's actually only 2 elements that are liquids
at room temperature.
At room temperature. Actually, we're only talking about assuming at room temperatures. And the 2 are mercury, and notice it's colored blue on this periodic table, and then bromine, and it's colored blue as well. And of course, gases, guess what? They're colored red. So if you look over at the periodic table, most of the, you've got helium, neon, all the noble gases are gases, of course, and then nitrogen, oxygen, fluorine, chlorine, etc. are also red. There's one other one you should also talk about. Of course, hydrogen is a gas. Okay?
A video.
So, elements, what do? You
look at the periodic table?
Yeah, just look at the periodic table. Bromine and mercury are your liquids, and then there's a few gases, and most things are solids.
Yeah.
Well, guys, I think that's like it. We're finished with 4.1.
Yeah.
You understand the reactions? We warmed our hands on the very, very cool ethanol. It's very, very warm. And now I'm hot. Okay. Well, we will see you in class or on the internet.